welcome back to a huge lesson. I know it has been months I've not uploaded. I was kind of busy with exams. So today we are going to be learning about atoms and molecules. I know this is out of the course, but before we proceed further in this video, don't forget to hit the subscribe button, like, share, and turn on the notification bell so that you will be notified when I upload any new videos or lessons like this. So I know, don't look at that drawing, that's horrible. I couldn't even draw properly. So let's continue. So before we start our lesson, some main important things are that we should know the terms that are we going to be using, because I'll just be teaching you. I'm just like, oh, so atom is that, that's molecule, that's your element, that's your compound. And you're just like, what's that? What's that? What's an element? What's a compound? So before I start this lesson, I wanted to clear you all of some terms. So first of all, the term starting from the lesson, atom. What is an atom? Atom is the smallest unit of matter. Atom is the smallest unit of matter. So now let's give you an example. Example. Oops, that's kind of wrong. Wait a minute. Okay. Now let me give you an example. Suppose I take O2. All of you know what O2 means, and who doesn't know, it means oxygen. So over here, O is the atom. What is O? O is the atom. And O2 means O plus O equals to O2, right? Okay. I recommend you take a small notebook or something to finish writing down these notes so that it would be easier for you to understand it. That's kind of gross. Let me just erase this. Whoops! Oh god! Okay. Oh. Wait. Okay. What? Okay, I think I'll just let that stay here. Okay. Next, let's go on to the term number 2. Based on the lesson as well, what's a molecule? A molecule. What's a molecule? When atoms are combined together. When atoms are combined together, they are called molecules. So suppose I combined oxygen and hydrogen together, so this is going to be called molecules. Let's give you an example. Let me get my line a bit thin. Okay, let's go. Now it means, suppose I take an example, H2O. Oops, let me just get that. Okay, now let me fix it. H2O. So over here, H2O, what does it mean? H2O means water. So over here, H2O, so it means hydrogen. Hydrogen is in 2 amounts, so H plus H. So hydrogen is 2, and oxygen is, whoa, that's a big one. Oxygen is 1. The same way, let's take CO2, ignore my writing, it's horrible. CO2. So over here, carbon is 1 and oxygen is 2. right? Okay. Next, let's go. Number 3, the term that I'll be talking with the most, so you should know this term. It is element or a compound, so you just make a slash. Well, they mean the same, but during the chemistry, they'll mean different. So element and compound. So element and compound when atoms and molecules are combined together, they are called element or a compound. There's a lot of spelling mistakes. Let me just find it. Okay, so they're called an element or a compound. Example, O3. You know the meaning of O3? Oh gosh, my O is so leany. Okay, O3. Ignore the fact that my O looks like a D. O3, it is an element. O3 is an O3 is an element, okay? Whereas H2O, oh my gosh, my handwriting is the worst. H2O is a compound. H2O, whoops, H2O is a compound. So why is it a compound? Because H2O consists of two things, hydrogen and oxygen. So the one that has two or more elements is called a compound, whereas that has only one element is called an element. Done? Okay. Now let's erase that as well. Oh my god. I think I erased the pool. Okay. Next, moving on. Chemical reaction. This is the most important term you need to know. Chemical reaction. Chemical reaction means the combination of both chemicals whenever you get a new product. Let me write that for you. Combination of both chemicals when you get a new product. So what does this mean? Whoops, I forgot to add the number 4. Wait a minute. Okay, now that looks better. Chemical reaction, combination of both chemicals when you get a new product. Let me give you an example. Now if I take water plus salt, so what will I get? Salty water? Salty water. Is this a chemical reaction? No, because you already know you have two combinations. You just mix them, you get the same kind of product. So this is not a chemical reaction. Oh my, where's my... Okay. This is not a chemical reaction. But if I take acid, which could be anything, plus base. Then it is equal to salt. It is equal to salt. So is this a chemical reaction? Yes. Why is it a chemical reaction? It's because you're mixing two products and you're getting a new product, which is salt. But on the first one, water plus salt, you didn't get any new product. You just got the same product, but just in a mixed form. So acid, you could take anything plus another base, which if you combine them together, it'll become salt. So that is a chemical reaction. Better write this down. It's going to come out in your exams. Now, number 5. Actually, I don't need to write the term because you guys got to know this. I'm going to just draw it on this first example. So over here, I want to tell you 2 new terms, reactant and product. Product is the one that comes after the finale. The final is called, the final item that you get is called your product. So if I ask you a question, now I added a new session, which I forgot to tell you about that. It's called a question. I'll make short videos, or maybe even after this lesson, I'll give you a question and you got to answer that on my comment section because I know I've been really late. I'm so sorry. Now, continuing on, this salt is a product. What's a reactant? The acid and the base together is called a reactant. What is it called? A reactant. R-E. Okay, I can't write with pens. Give me something that I can write with properly. Okay, I'm gonna wait a second, guys. I'm gonna come back with a Dieter diagram. Okay, so acid and base together, what are they called? They're used to make the product. So what will they be called? They will be called reactant. Whereas salt is going to be called the product. So you understand the meaning between reactant and product. Now I'm going to be moving on to new law, which is laws of chemical combination. I didn't write anything because I thought that I could write along with you guys so that you don't need to keep pausing the video. Law of chemical combination. So what are law of chemical combination? There are two main laws of chemical combination. Important, remember that. So if I ask you at the end of the term, how many laws of chemical combination are there? So you gotta answer. There are 2 laws of chemical combination. Main, okay, these are the main. So they were found out by, remember the names, okay, it's gonna get a bit tough. They were found out by Lavoisier. So it's kind of a tough name, but I think you can. And Joseph L. space and L. Proust. So these were the 2 scientists that found out the laws of chemical combination. So now the main question comes is that what are the laws? So the first law, it's a really important law. Law of conservation. Whoops, conservation spelling is wrong. Conservation of mass. This is the first law. And the second law is the law of constant or definite proportion. I know you're hearing maths and science, but it's okay. It's completely fine. You don't need to worry. So these are the 2 laws of the main chemical combination. So let's talk about law 1 first. So let's write law 1. What does law 1 tell us? According to the law 1 of conservation, according to the law 1 of conservation of mass, whoops, that's a big mistake. I'm so sorry. So let's talk, let's do it. According to the law of conservation, according to the law of conservation, mass of, conservation of mass, I'm so sorry, I'm really not well today. Matter can neither be created nor destroyed in a chemical reaction. So matter can neither created nor destroyed in a chemical reaction. Okay, so according to the conservation of mass, matter can neither be created nor destroyed in a chemical reaction. It remains conserved. So this is the most important thing to remain. If I ask you during your question session that explain me the law of conservation of mass. So you would answer, according to the law of conservation of mass, matter can neither be created nor destroyed in a chemical reaction. It remains conserved. It can neither be created. You cannot create it in a chemical reaction, neither you can destroy it in a chemical reaction. So that's very, very important to learn. So let me give you an example now, because examples are the one that will help you, remember more. So first of all, I will write over here. Let's see, acid plus base. And then I'll have to make arrows. So I'll just put that to equals to, please. And over there should be arrows. Equals to salt plus water. Okay, so this is our solution. I meant whatever I tell you, it's our reaction we're going to be doing. So let's take an example that your acid is about 5 grams. Example, okay? Your acid is 5 grams, okay? And then let's add a plus sign. And let's take an example. Your base is about 4 grams. Oh my gosh, it's so hard. 4 grams. So 5 plus 4 is equal to 9 grams, right? Correct. Whoa, okay, that's such a horrible writing. So it is equal to 9 grams. Whoops, 9 grams, okay? So will the salt plus water solution also be 9 grams? This is a really important question for you. Will the salt and the water together still be equal to 9 grams? Well, the answer is yes, because this is law 1. According to the conservation of mass, mass can neither be created nor destroyed in a chemical reaction. It remains conserved. So the formula over here, I'll talk to you about that. It's a really important formula to remember. So this will be equal to 9 grams. Let me write with it a red pen so that you guys remember it's important and just don't leave it behind that. And it might just be like that. Important. Important. So what is important? Rectant of mass, rectant mass is equal to the mass of product. This is our reactant, as we learned before. This is our reactant, acid plus base. This is called our reactant. So acid plus base, this is our reactant. These both are reactants. So reactant mass, okay, it's 9 grams, is equal to the mass. Our product is salt plus water. So it will also be equal to 9 grams. Simple. Now, if you guys want it with a more like sciencey example, it's drawing time. So let me draw. Let's see. This is an experiment. So suppose this is my beaker. I know, I'm a horrible drawer, but that's fine. This is my beaker, okay? This is my beaker. And then let's make a top on it. Whoops. Let's make a top on it. This is my beaker. Let's make a top on it. This, I have a chemical tube inside it. So let's say that this contains sodium carbonate. I know you guys are learning these terms first time, but it's okay. Go on Google, search periodic table. You'll get a bit of an understanding, or ask your parents. So where was I? I told that this is sodium carbonate, okay? And let's try to draw like maybe a colorful, I think so. So let's see, maybe pretend that this has like a pinkish type solution in it, okay? If you're laughing, then you're the worst. You guys stop laughing if you are, because I know I'm a horrible drawer, So this is my tube, and this is my solution. So let's imagine that this solution, that is a pink one outside, it is copper sulfates. So our solution is copper sulfate. Okay, this one. Okay, this one's copper sulfate. And this one, the guy who's out in the tube solution, it is sodium carbonate. Okay. Now we will imagine that sodium carbonate and the copper sulfate together, the total weight is 12 grams. Okay, that's right. Total mass is equal to 12 grams. And now, after some time, the solution, it becomes like this, okay? We mixed that up. We made a whole type of new theory with it, which is really nonsense. Okay, so this is what I made, and then this is my beaker, and now I'm gonna do something over here. Just 2 seconds, please. I know I'm not a good drawer. Okay, so suddenly after some time when we came back, this thingy, whatever it is, it turned into a bluish color. So that is the bluish color over there. This is a bluish color. So I'm gonna be like, huh? How did that happen? Just imagine that this is a final product, okay? And your tube is just empty because we mixed it. So the total mass will be, total mass is equal to 12 grams. Okay, guys, now wait a minute. I gotta do something. Okay, so guys, thank you for watching. I'll post it, the question and answers later. Bye. Bye.